In this video, I'm going to demonstrate how the intermodulation distortion test works. First, a little bit about what is intermodulation distortion. When you have two sines running, so let's start this up. And I'm going through a moderately old preamplifier, so it's got all these noise pieces in it. When I turn on the first generator, we get a peak at, in this case, 250 hertz, and we get harmonic distortion. Now, when I add a second generator, which will happen at 8 kilohertz, you'll notice that we not only get this, but we get all of these other things around it. Those are intermodulation distortion peaks caused by interference between the two sine waves. And we want to test that. So to begin with, you can see them by, if I turn on intermod markers, markers will come up at all of the places that are intermodulation distortion, not the harmonic distortion locations. So you can immediately tell where the intermodulation takes place. In addition to showing you the intermods, if you bring up the summary data, we show numerically the intermodulation distortion percentages. And the little letters here are defined, you can look them up, but they have to do with which fundamental is added to the other and how many times. In any case, you get both numerical data over here and you get visual data over here. Now, there are way more than one kind of intermodulation distortion, depending on what hardware you're testing and what you're testing it for. So the test has a whole set of industry standard intermodulations you can run. And when you pick one of these, because the intermod defines the two frequencies, you can't change them. And it defines the ratio between the two voltages. So the only thing you can change is the voltage of the fundamental. Whoop, there we are, here. So if I set this to 1/10 of a volt, you will notice that the fundamental will drop. And over here, this one will also drop. This is now 1/10 of a volt, and that is now 25 millivolts. Okay, so walking through each of these, for example, CCIF is a very common intermodulation. It occurs at 19 and 20 kilohertz, and in order to test that, we probably should run at 192K and maybe 128. So let's go ahead and start this at a higher sampling rate so we can get more high frequency data. But you'll notice, interestingly, that one of the intermods is here at 1 kilohertz, and it's pretty high, actually. So this is a nice way to test intermodulation distortion. If you want, you can always set this to custom, and that lets you pick the two frequencies and the two amplitudes that you test with. And that's a pretty good summary of intermod.